Hi, so we're streaming this today, so we are live. It is April the 8th. This is my wonderful fourth period class. Here we are, and I am making sure I got the stream going on my phone. Let me just turn down the volume to make sure that everything is okay. That way I can see the chat. So those of you who are watching live with me and you have a question, leave it in the chat so that I can see it. So last time we were together, Unit 12, Day 1, that was Friday, we were learning factoring. And I told you, yes, you can see the shortcut and you can jump straight to the answer and because you guys are brilliant. But please don't, because I want you to practice the technique, because we're going to do it when that first number isn't 1. So today, let's walk you through that technique when that first number isn't 1 and show you the not so very big differences between the two. Okay? So here we go. Here's our first one. Technique starts with identifying A, identifying C, and multiplying them both together. A times C is?
Negative 8.
24.
Oh, that's right.
Negative 24. Use a calculator app if you need to. List out all the factor pairs of negative 24.
1 and negative 24.
And also negative 1 and positive 24. And?
2 and negative 12.
2 and negative 12. And? And negative 2 and positive 12. 3 and negative 8. Negative 3 and positive 8.
4 and negative 6.
4 and negative 6.
Negative 4 and 6.
And then negative 4 and positive 6. Good. And so we're looking for the pair that when I add together gives me a negative 2. Which pair?
Maybe 4 and 6.
Yep, 4 and negative 6. Question coming in from the live stream, where am I getting these numbers? These are the factor pairs, the numbers you have to multiply together to get to 24. Thank you for the question from the live stream. All right, so these are the two numbers that when we add together give me that negative 2, and so I'm going to replace negative 2x with these numbers. That's a positive 4x and a negative 6x. The rest of my trinomial, my polynomial, I'm writing down without any changes. From here, create some groups. And then I'm going to place 2 things into each group. Just going to go in order, not thinking hard, making it all easy. Now I need to play the what do I multiply together to give me each of those things game. Okay, so I multiply 3 times x, and here I multiply 4 times x. The x's are what they have in common, so I'm going to write my x here and then create some parentheses, because in the parentheses I write what's left over. Notice how now I have more than one thing left over in each term. I just multiply those together. No big deal. If you don't have a sign on something, you assume it's positive, and so do write that positive, especially on the second term here. Right, this plus sign falls down. And I play my game again. But this time, I have a lot of choices of what I can write to multiply together. And so the ones I really want to look for is I want to get these to match. So for this first term, I want to be able to multiply something to 3x, because that matches this 3x, to get to negative 6x. 3x times what is negative 6x? Yeah, negative 2. Okay, I'm going to do the same thing here with the 4 and the negative 8. I need there to be a 4 because I want it to match this over here. 4 times what is negative 8? Negative 2. Very good. I now have matches here. Okay. And I'm looking for my common factor. There are the pairs. that are the same. That goes here on the outside. And then in parentheses, the stuff that I had left over. Which is an exact duplicate match to the one up here. And I did that on purpose because I wanted those two to be a pair, to be exactly the same, so then I could call them common factors and write them right here. And then I play my write down what's left over game again. Easy enough now that you've had like a weekend practice on this technique? Yes? Let's do it one more time. The numbers are a little bigger because there's going to be a lot more factor pairs, and I want to show you some tips and some tricks that you can use so that you don't have to write them all down, because here we wrote down a lot of numbers and that could be a mess. Okay, so let's go to this one right here. Game stays the same. A and C. A times C is a big number, which is negative 300. So we want to think, what are the factor pairs of negative 300 that when I add, give me a positive 5? Right? Okay. Let's simplify this a little bit. I'm going to take away one of the zeros. Let's look at just at the 30. What are the factor pairs of 30 that when I add, give me 5? Oh, well, let's not think about the adding first. Let's just do factor pairs of 30. 1 and 30.
Negative 1.
1 and 30. 2 and 15. 5 and 6. 3 and 10. Okay, so those are factor pairs of 30, but I was looking originally at 300. So on these, I'm going to have to multiply one of them by 10. I'm going to have to stick an extra 0 at the end of it. And then I want the addition of those to give me a 5. We're going to add a 0 to one of these numbers. Okay? If I add a 0 to this one right here, and knowing that one has to be positive and negative, so I'm going to make the small one negative, would that give me a 5? No. If I put it over here, would that give me 5? Okay, so that one's not going to work. All right, what if I put it here? Yes, but this gives me a negative 5, so I don't want the 20 to be positive, I want the 15 to be. I don't want the 20 negative, I want the 15 negative. Right? There it is, we found it. Okay, so when you've got a big number, if you can find some tricks to help make that number smaller, that could be very helpful and very powerful to you. Okay? It is okay for you to grab a calculator here and just start playing with numbers multiplying together. Okay? Just keep a list so you know which ones you've already thrown out and don't work. All right, we're going to play our game again. We're going to replace the 5. I'm going to copy everything else down without any changes. Make my groups. Put stuff into my groups. And then play the what are the factors game. This time I am going to write out the factors of 10, 2, and 5. Just because when I look at the other group, I see that I've got 15 and 30, and 15 isn't divisible by 10. Okay? And so if I pulled out a 10, it could make things more challenging on the next step. So I have 2, sorry I wrote in pencil, so it's, there we go. 2 times 5 times y for 10y squared. And then here I want to match up with these. I can either match the 2 or I can match the 5. Okay, so you want to match with the 5? Okay. And that was a choice he made. I had 2 factors here on this 10 that matched up with different factors in 20. So we got to choose. Did we want to go with a match on the 2 and list these factors as 2 times 10? Or did we want to go as a match on the 5 and list these factors as 2 times 5? In the end, it doesn't matter, it's your choice. He chose the 5. Oh wait, but I could do a 2 here too, can't I? Wait. Look. If I do this, okay, if I do that now, I can match all of it. Yeah? Because we want the biggest factor we can get. We want to match as much stuff as we can. Okay, so then let's do this to match all the stuff that we can. Is that okay? Yes? 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 Yes. Okay. So out here now in front, I'm going to write what they had in common. They had 2 times 5 times y for 10y. And then in parentheses, the stuff that was left over. So this was a y, and this was a 5. My plus sign, bless you, is going to fall down, and I'm going to play the game again. But I want stuff that's going to match right here. Where did I get this other 5? Where did I get that other 5? Oh, it's supposed to be a 2. You're right. Because it's 2 times 2 times 5. Oh, my goodness. There we go. Thank you. Thank you. Thank you. Caught that before the live stream saw it. I could already see her getting ready to type. She's like, no. So then this is a 2 down back here. Okay. Sorry. That's a 2 down there. Because that's what... Okay. Better? My numbers now? Okay. Thank you. So now we're wanting to match the y to here. So I want y times something to give me negative 15y. Negative 15. Here I want something times 2 to give me negative 30. Negative 15. And so the negative 15s are what we have in common. And in parentheses, the stuff that's left over. I can then write my group that is the same, and then in parentheses, the stuff that was left over. Okay, thank you for checking on the numbers. That tells me that you guys are feeling much more comfortable with this technique. All right, questions on the technique? Nope, all feels really comfortable. And so the big question that I'm sure that a lot of you have right now is, fantastic, why do we care about this now? Like, really? What's the point? Okay. There's got to be a point to this. Because, what if I gave you that? And I said solve. Okay? Adjust your notes really quick, okay? I added a couple things. So take a moment, adjust your notes. In order to solve these things, you have to make use of something called, and I'm going to write it here right in the very middle of our page, something called the zero product property. The zero product property is a very, very powerful tool that comes straight off of factoring, and what it says is this, is if you have some stuff being multiplied together and equals 0, then I can think of this one equation as different equations where each thing I'm multiplying is 0. Because if I have a whole string of things multiplying together to be 0, all it takes is one of those things to be 0, right? And then the whole thing is 0. So this allows me to break it up into the different factors to figure out which factor is the one that's making the whole thing equal to 0. This is what it would look like. So if I come back to this one, and if I say solve, it's equal to 0. Okay, all I'm doing is adding equals 0 the whole way down. My very last line, my fully factored form says stuff times stuff equals 0. That's what zero product property says I need to start with. Since I have it, I'm going to take this first group of stuff equals 0. I'm going to take the second group of stuff equals 0. Then I'm going to ignore everything above those two equations, and I'm going to solve those very simple linear equations for 0. which is all seems very simple and straightforward to do from here. We're just going to subtract 4, and then we're going to divide by 3, and so x equals negative 4 over 3, and here all we do is add 2, and so my two answers are those things. I saw a thinking face. Ask your question. So from here I subtracted 4 from both sides, and then I divided by 3. And on this side I just added 2.
Oh.
Okay. That's it. Those are my answers. So all the really hard work was done in the factoring, which you guys are getting much better at. Then as soon as you get it to factored form, you write the two equations and you solve those, and it's done. It only works, though, if you have it equals 0. And so the big question is, yes?
Before you put the equals 0, what would have been the answer to the...
Up here?
Yeah.
You can't find, like this, I'd have to stick in a calculator and see where this graph passes the x-axis, which it may or may not.
For writing it down and stuff, like, what would you
What would you box? These. If told to solve, you're boxing these.
And if not,
If you're told to factor, then you box that.
okay.
Okay, so this question is, what's my final answer? What do I put a box around to say I'm done? If the directions say factor, it's this. If the directions say solve, it's these. Okay, so the question now is, if it's not equal to 0, what do I do? Make it equal 0. The zero product property, because you have the word 0 in the name, your equation has to equal 0 in order for it to work. How do I get this side to be 0? Add 4. And so this becomes 4x squared minus 3x minus 1 equals 0. And now I can factor the thing using the technique from above. Believe me that I've already done the work, and I can have it out here available if you want to look at it. That's how it factors. And then zero product property says that I can take each one of these factors and set them equal to 0. I skipped all of the work because I did it over here. Okay, so between this step and this step, we had to factor. This was me using zero product property. And then between these two steps was me solving for x. These are my final answers. Questions? What if there was no -5, no third term? Are you already glancing at the homework and seeing you've got things with 2 terms? No? Oh, good. But I still love I love the question anyway. Okay, so so you're saying, what if I had this thing, but it was just like that? What would I do here? I love this question. Let me save this question for... No, you know what? I could answer it now. Same idea. We'd still use zero product property. We just have to factor this, and we can't use sum and product. So this would be that greatest common factor, this stuff right in here. Okay. So when I would factor this, it would look like that. And now I've got stuff multiplying together equals 0. So that can be 0, or this could be 0. This one's already solved and done. There's my result for that one. There's my answer.
So if it's 4x minus 3x equals -4, and we change it to 4x to minus 3, but plus 4.
Yes, I would move this one over. And then I would start factoring. And I'm glad that you guys are asking these questions because this rolls right into the very last 4 items on the homework assignment I gave you where you have this thing. Like the other 2 examples, a term was missing on the left. But in this example, it's that b times x term that's missing. And I don't have it appearing on the right-hand side to just kind of move it over and get it to appear. So on this one, my recommendation is add it in with a coefficient of 0.
That one's easy to solve.
Yeah, and then what you're really looking for is you're looking for factors of negative 64 that when you add, cancel each other out.
Why not a coefficient of 1, so like 8?
Exactly. Her question was, why a coefficient of 2? Why not a coefficient of 1?
Why a coefficient of 0?
Yeah, why a coefficient of 0 as opposed to a coefficient of 1? Because 0 times this is 0. And because this wasn't here, there was nothing there. 0 is what we use to represent nothing. And so I'm adding in nothing. If I put a 1 as that coefficient, I'm suddenly adding in 1x. I'm adding a quantity. I'm changing the value. Fabulous question. As you're working through these, be watching for a pattern to emerge. Okay, I already had people say this thing is going to factor to one of them with a +8, one of them to a -8. With these 4 questions I've been giving you, look for a pattern similar to this. Okay, do all the steps, but watch for that pattern. Because, spoiler alert, I'll tell you the shortcut pattern for when you see these another day. I'm so mean, I'm so sorry. That's all I had, unless you guys had any other questions.
Thank you.
Thank you. Last questions from the stream.
Sorry, I'm not finished watching.
That's okay. That's all right. I appreciate you kind of having an ear in both worlds.
Bye.
All right. Bye. Say bye to YouTube because it's already posted.